Question from electromagnetic force from the electrical engineering paper from the magnetic field part. The infinite surface of linear current density K equal to 5 AX ampere per meter exists on a XY plane. The magnitude of the magnetic field density at a point 111 due to the surface current in magnitude is asked. It's a very simple question, right? Directly someone can see and someone remembers his answer is going to be 2.5. Okay, ampere per meter. Let us see how it is. Look at this. So this is a region where the sheet of charge is there. This is X, Y. This plane, the infinite sheet of charge is there. We have to find out the electric field at this point. Whether electric field at this point or any other point, doesn't matter, the answer will come same. Because the magnetic field due to infinite sheet of charge is given by 1/2 times K vector cross normal component. Okay. So what is normal component? Along the z direction. So 1/2 times K is given as 5AX cross AZ. AX and cross AZ is going to become 2.5 times. AX cross AZ is going to be minus AY, right? This is magnetic field value. Magnitude of magnetic field is going to be 2.5 ampere per meter. Answer is 2.5. Okay, that's it. Okay. So whether if question says about any other point or whether anywhere it is going to be. Okay. That's the end of question for EMF from electrical engineering paper. Question from electromagnetic fields in electrical engineering paper. The question is basically about electric and magnetic fields acting on a charge. We have to see by looking at these statements, which of the following statements may be single statement or multiple statement may be true. So first thing that is mentioned in the question is slightly different from the figure, that electric field is along the z direction and magnetic field is along the x direction. Okay, that we can see from the figure. But in the question it is mentioned electric field along the x direction, magnetic field along the z direction. Okay, so there's some mismatch. So leave aside that mismatch. Okay, if the question can be treated that question is wrong or figures are not matching, marks to all can be given. But at least we should understand what is happening here. We'll assume that the figure which is mentioned, that way the electric and magnetic fields are there. Okay. So let's see. So if I look at the magnetic field, the charge is at rest, right? So if I look at the electric field first, so electric field vector is charge Q multiplied by electric field along the AZ direction. Okay. So the acceleration I can write is QE on N along AZ direction. Okay. From this I get the velocity Vz is empty integral of this AZ direction. So this is what the acceleration. Now you see the charge is moving in the direction of z with constant velocity. Is the velocity is constant? No, the velocity is not constant. Velocity is dependent on time. And as the time is changing, the velocity is also changing. Right, so that is one part. Right, so first statement is not correct. Right, so charge will move along the direction. Let us see further and see what will happen, the effect of this on the magnetic field. Now the force magnetic field is Q. This charge is moving along the z direction, so this Vz cross and the magnetic field along the direction. Okay, so that we can write this as Q. Z cross X will become Y. That will become Q. QE by MT B AY. Okay, that will become Q square E T B I N. That is the estimation part. Escalation due to electric field, escalation due to magnetic field. This will move along the y direction. And from here, if I write Vy, this is the y direction, it is q square integrated for t square by 2n. And here once again, m square will come. This is the only m square. This is along the y direction. So the charge will go in y that plane. That is for sure because we got the velocity in that direction, velocity in the y direction. So this is true. Right. Now dy by dt. dt by m dy. So it is positive. So dy by dt, the charge will progress in the y direction. Yeah. That is true. So because velocity is progressing in the direction y. Right. Next, the trajectory of the charge will be a circle. This is possible when you have an equation of like y square plus z square, something equal to constant, or a helical kind of thing. But that is not coming out in this case. So because the electric field and magnetic fields are just giving us their constant magnitude, right? They're not changing magnitude. So this second order derivative which will give me in circle, that will be 0. So that will not come as a part of a option C does not seem to be true. Okay. Otherwise, by looking at the statement of this and the figure, they are not matching. So maybe the benefit of the doubt can be that benefit can be given to all the students. But for us, it is coming like option B and D are correct. Okay. Okay. That's this end of this question.